Hello viewers, you are welcome to this channel once again, and today we'll be looking at the topic variation. So when we talk about variation in mathematics, it is used to describe the relationship between two or more quantities. Now, in solving variation, there are different types of variation. The first one is the direct variation, the next is inverse or indirect variation, and the third is joint variation, while the last one is the partial variation. Now, for you to be able to solve variation very well, you need to know the difference between each and every one of them. When you see a question, you need to be able to identify either it is direct or inverse before you can actually successfully solve any question in variation. Now, when we talk about direct variation, when the ratio of x to y is always constant. That's, for example, when we have x increasing and y also increase in proportion to x, then we say that this is what a direct variation. Or when x decreases and y decreases as well, it is known as direct variation. Now, a typical example of direct variation is the circumference of a circle and the radius of a circle. So the circumference of a circle is directly proportional to the radius of a circle. Also, when we have a car moving at a constant speed, the time taken and the distance for that car to get to where it's going to is what? Directly proportional. So we'll be solving some problems under direct variation. After that, we'll discuss more on the other kind of variations, and then we solve problems relating to each and every one of them.
So if P varies directly as Q and P is equal to 8 when Q is equal to 2, find Q when P is equal to 40. So as we explained, this is a direct variation question. So first of all, we are actually going to find our constant. Okay, let's define this question. We have solution. P varies directly as Q. It implies that P is equal to KQ, where this K is what? Is the constant. So we now have P equal to KQ, and then I said P is equal to 8 when Q is equal to 2. Find Q when P is equal to what? 40. But first of all, we are going to be finding our K, which is the constant. And when we get our constant, we'll get the equation that connects each and every one of them together. Then we go ahead to find our Q when P is equal to 40. So for P, the first information given to us will be used in getting the constant. They say P is equal to 8. So P equal to KQ. P is 8, so we have 8 equal to constant, and Q is 2, so we have 2. This will now give us K equals to, dividing both sides by the coefficient of K, which is 2, we have 8 over 2 equal to 4. So we've gotten our K as our constant as 4. So the equation connecting this thing, the equation connecting them is P equal to 4Q. So with this equation, we are going to be finding our Q when P is equal to 4. So when P is equal to 40, sorry. So P is equal to 40 equal to 4Q. So we divide both sides by 4, which will give us 40 over 4 equal to Q. So Q is equal to 10. So when P is equal to 40, our Q is what? Our Q will be equal to 10. So the second example, if x varies as the cube of y and x is equal to 3 and y is equal to 2. The first question is find x when y equal to 4 and then find y when x equal to 40. So remember, first of all, we'll define our equation. This is a direct variation. So we have x varies directly as the cube of y. So cube of y is y to the power of 3. This implies that x is equal to k, which is our constant, y cube. So first of all, we have to get our constant, which is k, and how to get this, we use the first information given to us, x equal to 3 and y equal to 2. So where x is what? X equal to ky cube. So our x is 3. We are looking for the constant, remember, which is k, and we have y equal to 2. This will now give us 2 all to the power of 3, which will be 3 equal to 2 raised to the power of 3. That is 2 times 2 times 2, which is 8. So we have 8k, and we have k equal to, divide by the coefficient of k, we have k equal to 3 over 8. So since we've gotten our constant, we'll move over to finding the first question. We are asked to find x when y equal to 4. But remember, the equation connecting the 3 variables now, which is x, y, and the constant, the equation connecting them will give us x equal to 3 over 8 y cube. So we'll be using this equation to find x when y is equal to 4. So we are looking for x when y is equal to 4. We have 3 over 8. So our y will substitute 4 for y, which is 4 raised to the power 3. This will then give us x equal to 3 over 8. So we have 4 raised to power 3 is 64. So this will give us x equal to 3 times 8. Yes, the 64 going to 8 will give us 8. So 3 times 8 is what? 24.
So for inverse variation, when the relationship between two variables is such that as one increases, the other decreases, or as one doubles, the other becomes half of it, and vice versa, we say that is actually an inverse variation. So one typical example of an inverse variation is the volume of a gas and its pressure. They varies inversely. So let's solve some problems under this inverse variation.
So we have arrow varies inversely to the sum of m and n, where m equal to 4 and n equal to 3 and arrow equal to 8. We are asked to find the value of m when n is equal to 47 and arrow is equal to 8 over 3. So first of all, we are going to be representing this inverse variation in. So we have arrow varies inversely. So this will give us varies inversely 1 over to the sum of m. And when we talk about sum, it has to do with addition, which is m plus n. This implies that arrow is equal to k, which is a constant, over m plus n. So we are going to be using the first information given to us, m equal to 4, n equal to 3, and r equal to 8, to get the value of the constant k. So arrow is what? Arrow is 8 equal to k over m is 4 and n is 3. This will give us 8 equal to k over 7. So cross multiplying, we have k equal to 8 times 7 will actually give us what? That's 8 times 7. K equal to 56. So we'll be using this constant to get the equation that connects all of them. So this will give us r equal to 56 over m plus n. This is the equation connecting each and every one of them. So from here, we are asked to find m when n is equal to 47 and r is equal to 8 over 3. So our r is 8 over 3 equal to 56 over, we are looking for m, and n is 47. So cross multiplying, we have 8 bracket m plus 47 equal to 56 times 3. So 8 times m is 8m plus 8 times 47 is 141. Yes, 141 equal to 3 times 56 is 168. Okay, this is 376, sorry. So we have 8m equal to 168 minus 376. We have 8m equal to minus 168 minus 376. This will give us 208. Yeah. So to get our m, we divide both sides by 8. This will give us m equal to minus 208 over 8. M will be equal to minus 26. So the second example under inverse variation, we have x varies inversely as cube root of y. When x equal to 7, y is equal to 8. We are asked to write the equation connecting x and y. Then we'll find x when y is equal to 64 and also find y when x is equal to 4. So we are going to be taking it step by step. First of all, we are meant to understand that x varies inversely as cube root. So the cube root of y is this. This implies that x is equal to, so introducing our constant k, equal to cube root of y. Now, first of all, we will be using x equal to 7 and y equal to 8 to get the value of our constant. This will give us x as 7 equal to k over cube root of 8. This implies that 7 equal to constant over the cube root of 8 simply means what number will you multiply 3 places to get 8, and that is 2. That is 2 times 2 times 2 into 3 places. So the cube root of 8 is 2. Cross multiplying, we then have k is equal to 14. That's 7 times 2. So write the equation connecting x and y. So the equation connecting x and y becomes x equal to 14 over cube root of y. So we'll start the first question. We are asked to find the value of x when y is equal to 64. Value of x when y is equal to 64. So x equal to 14 over the cube root of y. Find x when y is 64. It means we have 14 over cube root of 64. Yeah. So this implies that x is equal to 14 over the cube root of 64 simply means which number will you multiply into 3 places to get 64, and that is 4. So x equal to, using 2 to divide both of them, we have 2 into 14 will give us 7 and 2 into 4 will give us 2. So when y is 64, x is 7 over 2. So the second one, x equal to 4, we are asked to find y. It implies that we have, remember the equation connecting them is x equal to 14 over the cube root of y. Simply means that our x is 4 equal to 14 over cube root of y. So this is the same thing as 4 brackets the cube root of y equal to 14. So we have 4 14. So dividing both sides by 4, we have the cube root of y. That's the cube root of y equal to 14 over 4. So when you have this kind of mathematics, to resolve it, we'll take the cube of both sides, giving us y equal to 14 over 4 raised to the power of 3. This will give us 2744 over 4 raised to the power of 3 will give us 64. So if we use 8 to divide through, 2744 divided by 8 will then give us 343 over 64 into 8 is 8. So when x is 4, our y is 343 over 8. The question says v varies jointly as the square of x and inversely as y. If v equal to 18 and x equal to 3 and y equal to 4, find v when x is equal to 6 and y is equal to 9. So v varies jointly as the square. V varies jointly as the square of x, that's x squared, and inversely as y. This implies that v is equal to kx squared all over y. So for us to get the value of our constant, we'll be using the first information, which is v equal to 18, x equal to 3, and y equal to 4. So v is 18. Our x is 3. Remember, x is squared. So we have 3 all squared. And our y is 4. This will give us 18 equal to 3 times 3, which is 9. 9k all over 4. When we cross multiply, we have 18 times 4, which is 18 times 2 is 36. 36 into 2 is 72. Yes. So we have 18 times 4, which is 72, equal to 9k. So k will become, dividing both sides by the coefficient of k, which is 9, we have 72 over 9, which is equal to 8. So we've gotten our constant as 8. So establishing the equation connecting both v, x, and y, we have v equal to 8 x squared over y. So since we've gotten the value of the constant, we'll then move to finding v when x is equal to 6 and y is equal to 9. So v is equal to 8 bracket, our x is 6, that's when x is 6 all squared, and y is 9. So we have v equal to 8. 6 times 6 is 36 over 9. So v will give us 8 times 36 is 288 over 9. So v is equal to 32. So this that's for joint variation. The next one is partial variation. A number p varies directly as q and partly inversely as q squared, given that p is equal to 11 when q equal to 2 and p equal to 25.16 when q equal to 5. Calculate the value of p when q equal to 7. Now this is partial variation, and remember, for partial variation we'll be having two constants. So defining this particular question, they said a number p varies directly as q. Let's say our first constant is a, q, and partly inversely as q squared. Now when we defined our partial variation, we talked about having two sums, right? So this will be plus inverse variation. The second constant becomes b equal to partly inversely as q squared. So we have q squared. So a number p varies directly. So our first constant is a to q and is partly inversely as q squared. So this inverse variation. So having gotten this particular equation, we'll go ahead to use the first information, p equal to 11 when q equal to 2, to get our first equation. So before we can resolve this thing, we'll first of all get the first and the second equation. Then from there, we get our constants a and b before we can go ahead to calculate the value of p when q is equal to 7. So for us to get the first equation, we are given p equal to, okay, let's say when p equal to 11, q is equal to 2. So p is 11, we have 11 equal to 2a plus b over 2 all squared. This will be 11 equal to 2a plus b over 2 into power 2 is 4. So multiply through by 4. We have 4 times 11, which is 44, equal to 4 times 2 is 8a plus b. So first equation becomes 8a plus b minus 44, or equal to 44. Let's put it like that. This is equation 1. So to get the second equation, the next value given to us is when p equal to 25.16 and q equal to 5. So remember, the equation is p equal to aq plus b over q squared. So if p is 25.16 equal to our q is 5a plus our b we don't know, then q is 5 all squared. This will give us 25.16, that's 25.16 equal to 5a plus b. 5 squared is 25. So we'll be multiplying through this equation by 25. 25.16 times 25 will give us 629 equal to 25 times 5 is 125a plus b. So this is equation 2. So this is equation 1 and 2. So we'll resolve these two equations simultaneously to get our constants a and b. So let's subtract equation 2 minus equation 1. This will give us 125a minus 8a, which is 117a b minus b is 0, so that one is eliminated, equal to 629 minus 44 will give us 585. So from here we can get our a. A becomes 585 over 117. So a is equal to 5. So having gotten our a, we can substitute 5 for a into any of the equation, either equation 1 or equation 2. Okay, let's go with equation 1. Substitute 5 for a in equation 1. This will give us 8 of 5 plus b equal to 44. 8 times 5 is 40, right? Yes. 40 plus b equal to 44. So b is equal to 44 minus 40. b is equal to 4. So we've gotten our two constants as a equal to 5 and b equal to 4. So we are asked to calculate b when q equal to 7, having gotten our a as 5 and b as 4. Remember, the equation is b varies directly as q and inversely as q squared. So we are calculating p when q is equal to 7. But remember, a is 5, so we have 5 bracket 7 plus b is 4 over our q squared is 7 squared. So p is equal to 5 times 7 is 35 plus 4 over 7 times 7. That's 7 squared is 49. So we have p equal to 35 plus 4 over 49. This will give us 49. 49 into 49 divided by 149. 49 times 35. 1715 plus 49 divided by 49 is 1. 1 times 4 is 4. So p is equal to 1719 over 49. This is an improper fraction, so if we resolve it to becoming a mixed fraction, it will give us p equal to 35 whole number 4 over 49.